Paddling with the current, Zoe can travel 48 kilometers in 3 hours. Against the current, it takes Zoe 4 hours to travel the same distance. Find Zoe's rate and the rate of the current. So this question has two competing rates in it. We have the actual rate of Zoe's boat, and we have the actual rate of the current. Zoe's rate is what we consider to be the still water rate. What would her rate be if the water did not have a current? Imagine that she was paddling on a lake. In that event, she would have a fixed speed. But because of the presence of the current, that would adjust her speed depending on the direction that she is traveling. Before we begin writing our equations, we're going to start as we always do by defining our variables. Let x be Zoe's, or the still water speed. They called it rate in the problem. And let y be the rate of the current. Both of those are speeds, and looking at our units of measurement in the problem, they're both going to be in kilometers an hour. When Zoe is traveling with the current, she's able to complete the 48 kilometer distance in 3 hours. But because she is paddling with the current, she gets a bump from the current and is able to go a little bit faster. So her speed is added to the speed of the current. But as she is traveling back, she's going to have a little bit of a harder time. And you can see that right from the jump. It took her 4 hours instead of 3 hours. In this situation, instead of receiving a bump from traveling the same direction of the current, she actually is slowed down by the fact that the current is going the opposite direction. Looking at these two equations, we can notice that 48 is divisible by 3 and 48 is divisible by 4. This isn't always going to happen. You may need to distribute and solve through elimination or substitution, but in this instance, you can actually get away with dividing away this 3 and this 4 from both sides of their respective equations. And when you do that, you create a new system that looks like this. Just like we could multiply both sides of an equation in a system by the same number and create a new equivalent equation, we can do the same thing with division. At this point, we can use elimination and we can add down. X and x makes 2x. Y minus y is 0. There's the elimination of the one variable, and 16 and 12 makes 28. Dividing by 2, we get x is equal to 14, and then back substituting that back up here, we get x is equal to 14. Back substituting that back up here, we know that 3 times 16 is 48, so I need this other number to be a 2. And if you want to check your work in the other equation, I know that this is going to be 14. I know that 4 times 12 is 48, so I need to lose 2 miles an hour in order to get that prescribed distance. So we can end with saying that Zoe's still water rate, traveling as if there was no current, would be 14 kilometers an hour. The rate of the current, 2 kilometers an hour.